for the case of differentiable, I mean, there's a question at limit. There's a limit question of something like this. Is it differentiable? Okay, this is new black pen. It's not as thick as it used to be. Okay, for you to be able to solve this question, you don't have much of a choice. You must memorize this line. And I'll be honest with you, every semester I forget. Okay, so mau tak mau, if you want to be able to solve this question, you must memorize this formula. It's not given in exams. If you forget, then there's nothing I can do. Okay, so far, how many times has it come out in exams, sir? Only come out twice, if you look from 2011 until last year. And then again, only once you can do, until 2015, it only come out twice. So one of them you can do, another one of them is super hot, so chances very low. I don't complain much if you cannot do. Okay, how do you solve this question? The equation is something like this. It's question number 11. Another one is 18, right? Another one is 19. But 19 is difficult. The question goes something like this. You are given this equation. Let's say this is your equation. Solve it this way, is it? Okay, just substitute the Q with the 4 because it says there. And they ask us, does fx differentiable at x equals to 1? Let's go something like this. So how do we translate the formula? This formula for this question, it will be something like this. Limit x approaching, in this case is a, so or you might want to say number in our terms, the one that you learn in my class. This is number, FAS, number, AS number. Easier to memorize that way and easy for you to understand. So x approaching what? You go 1 because you want to test at 1. How do I know whether limit exists? Apa syarat dia? What's the rules? Left and right? Same. So x approaching 1. First, we do this one first. So fx minus f1. I'm not saying Formula 1. Anybody here is a big fan of Formula 1? Please raise your hand. Nobody like Formula 1? Except for Kimi Raikkonen, that's different story. Okay, so let's begin. Okay, what do you know about F1? This one here. We have done something similar. This is what? This is the F number lah. Right, when it's equals to 1. So when it's equals to 1, which formula should I take? First or second? First, so it's related to this one. So I'm saying right now, F1 equals to 2, 1, minus 1. So F1 is equals to 1. You okay there? So right now we got ourselves, we can retranslate this formula into limit x approaching 1 fx minus 1, you are right. Let's try the red one. So at the bottom you got yourself just simply x minus 1. Okay? So what about fx? Which one should I choose? First or second? If it's continuous, then your answer is right. We choose second. Just now I asked you already. How do I know whether limits exist? You need to check the left and right. So at this moment here, this equation becomes 2. Oopsie. Limit x approaching 1 from the left. Another one is limit x approaching 1 from the right. If 1 from the left, fx should be what? First or second? First. Left is less. So 2x minus 1. So that also means from the right will be second. So this is the second. Let's put it more recognizable. 4x squared minus 3. Minus 1, right? Over x minus 1 over x minus 1. You okay?
Sir, tadi saya tak buat lagi kiri kanan tu macam mana saya tahu kiri kanan dia sama?
Repeat your question again.
Saya kat limit exist but kiri kanan sama.
If the kiri kanan sama, left and right the same, then limit exists. Right now we do not know whether it exists.
Oh, so
Yeah. Okay. Firstly, you need to check whether it's differentiable lah. Then this is how you want to check. Now we want to check the limit here. So you need to check left and right. I do not know yet whether the limit exists. We are going to find it out. Okay, of course, if you put 1 here, denominator becomes 0. That we do not want that case. So let's try to solve this one. Can I give you 1 minute to solve? Try it. Viewers, try your best. You should know the skill by now. Okay, if you manage to solve them, you should be able to get yourself. This is 2. Another one is 8. Try and get it by yourself. Okay, the one on the right here, if you open the bracket, you should be able to get yourself. This one, I should get myself 4x squared minus 4. Am I right? Which I can also rewrite it as 4x squared minus 1. You got that? X squared minus 1, can I factorize it? What do I get? 4x plus 1, x minus 1. So what happened to our equation then? Yep, that's a good clue enough for you. On your own, not interested. Unless if you over rely on your calculator, that's very different story, yeah. I think if you use your calculator, you just get x plus 1, x minus 1. You don't get the 4, am I right? Don't over rely on your calculator. Certain things you should be able to do it on your own. If it's tough, then only you do it with your calculator. Okay, you got 2, you got 8. What does it mean here? The limit does not... you need to say first is dia tak sama. You are right, it's not the same. Then only you need to say they does not exist. So here we're saying that one from the left, fx, minus f1, x1 is not the same as fx minus f1, x minus 1. This is not your normal limit, okay? This is differentiable limit. It's very different case. Yeah, not the same. Another one is 2, another one is 8. So fx, maybe it's different color. The conclusion is fx not differentiable at x equals to 1. Alright? This is how you solve them. So far the chances for it to come out is very, very low. So yeah, you need to memorize the steps. Memorize this formula. If you memorize this formula, then I think you should be quite fine. So every year I forget them, I'll be honest with you. But once I get this formula, then I'll be fine. If your limit is good, your basic limit is good, you should be fine. Okay, can I move on? Do you want me to? There's nothing to repeat. Just you need to remember that f number is choose yang equal. Like this one here, f1. We choose your equal, and then we substitute, we put inside. So f number become 1. Okay, moving on.